Now let's talk about the inverse of a function. The inverse is simply the reverse of a function. In the example below, you have a function where the x value represents the year and the y value is some number. So notice, if you were to swap your x and y's, which is what we did here next to it, you have then what is called the inverse of that function. Notice that the numerical values is now my x value and the year is now my y value. So we can find the inverse of a function by simply swapping the coordinates of each ordered pair in the relation. Now you must note that for a function to have an inverse, the function must be a one-to-one function. And the symbol, what you see of the function with a -1 as its exponent, represents the inverse of a function. So anytime you see this symbol, this is the inverse of the function itself. Here we want to find the inverse of each function that is one-to-one. So recall, for a one-to-one function, it would be a one-to-one as long as no two y values repeat themselves. And in this function, we can see that for the 1 and 2, they repeat themselves. So it is not a one-to-one, which means that it does not have an inverse. Let's take a look at the next example. All we need to do is check to make sure none of our y values repeat themselves. They do not. So that indicates that this is a one-to-one function and it does have an inverse. And to find its inverse, all we have to do is swap the x and y values and we have the inverse of that function. And notice we write it with a -1 as its exponent to represent that it is the inverse of the function itself. Here is a graphical representation of the inverse of a function. The graph of an inverse is simply a reflection or mirrored image about the line y equals x. So anytime you're given two functions, you want to know graphically if they're inverses of each other. If they form a mirror image about that line, then yes, they are inverses. Here's another function and its inverse, and notice it forms a mirror image about that line y equals x.